Hi there and welcome back to part 7 of my MLAPI tutorial. I'm SR Coder, and in this one we're going to cover networking this across two computers. Currently we're only working, as you can see, we can only really join a game on localhost, and that was deliberate because we were just trying to make it really as simple as possible, and I'm going to show you the next couple of steps that we need to take in order to make sure that we can connect across computers. Obviously, a disclaimer right now, you can connect across computers as long as the network is set up correctly and there's no firewalls and things getting in the way, but I'll show you the basic process of doing this, assuming that there's nothing else getting in the way of that. So the first thing we really want to do is allow this join game button to connect to a particular IP address. So if you look at the network manager, you can see down here that there's no place inside of the standard network manager that you can add the IP address. The IP address actually comes from this component, the UNet transport, and that's obviously dependent on the transport you're using. So assuming you're using UNet transport as your network transport, then everything should follow along, but it's pretty much the same should you choose to use one of the others. The connect address you can see right here is 127.0.0.1. That's a standard localhost address. So if you want to connect to localhost, you would use that address, and then when you connect, you use that address. This connect address part of the UNet transport is the thing that we need to change. So let's just go ahead and do that by creating this extra space inside of the UI. So we'll jump straight to the game canvas right here, and we've got this panel that we put everything on. So we have this join button, and what we want to do is we need somewhere where we can input the actual IP address. So I'm going to right click on this game panel, so it's still a child of that game panel, go to UI, and I'm going to type in, I'm going to choose the input field. So this input field, you'll see it's in the middle here, and it's by default it says enter text. So I'm just going to go into my scene view so I can edit this into 2D and double click the panel, and then I'll just zoom in a little bit. So I want this below the join game button, and I want the default text to say something different. So I'm going to drag it directly underneath so that it's directly under. And then the default text, you can see if we go for the input field, there's placeholder, and this is the default text. So I'm going to change that to enter IP. We could, for this text, this is what's going to be filled out. We could put a default value in here so that the player doesn't have to type anything in. So this 127.0.0.1, and that will automatically go to that local host. But we could do that in code as well. So I'll maybe stick with the code part actually. But if you see here, this placeholder text says enter IP. The top level join button, I'm actually going to change the text to just join, and hopefully the user, I mean, it can organize this better, but hopefully the user will know that they're going to be joining the IP here. You could place them side by side if you think it looks better. We know what we're doing, so we're going to leave it at that. So I need the menu script obviously to do something. It needs access not only to this menu panel, but we need to be able to read this data when we click the join button. So I'm just going to save this scene because I have made some changes to it, and we're going to open up the script, the menu script that's on the game canvas, and then we'll make the changes that we need in order that we can get that IP address and place that into the transport when we click the join button. So we've got our two methods here. We've got the host and the join. Right now we just join the default value that's set in that connect address. So I'm going to need the input button. So what I'm going to do is add the using from the Unity engine, unityengine.ui, so that I can have access to the actual input field, and then I'm going to create a public input field variable, and we'll just call it input field for no other reason. And then we're going to be able to get with this input field, when we click this join button, we're going to be able to get this input field value and place it where we need it to be for the network manager to be able to start the client. So if you see we can get input field dot, and we can find what it is. Is it the text input field? Oh, I've done the lower uppercase, so I want lowercase one. Input field dot text. If we get that, what we'll actually get is the actual address that we want to join, and where we have to put it is we need to put it into the correct place in the transport. So we need to get a hold of the transport. The transport component, if we go back here, the transport component on the network manager is actually the UNet transport. It's the one that we used. So we need this component so we can set the connect address, as I've mentioned. So what we need to do is, I was playing around and practice, make sure I was getting this right for you guys. The MLAPI.transports.unet will give us access to that transport. So if we want the transport, what I'm going to do is I'm going to just call it that we need to get the component of the network manager. So we're just going to say that the networking manager.singleton.get component, and then it was UNet. Let's type in transport and see what we can get. UNet transport, there we go. So once we have that component, we want to set the connect address and make that equal to whatever this input field dot text was. So this obviously will get fired when we click join. I should comment that. Click to join. So it's going to read. We don't need to set up any other when it changes or whatever. We'll just, when we actually click this join, we're going to get the connect address and set that correctly. What we should probably do is check that it's not empty when we do that. So we should maybe just go above in here, and we'll just say if input field dot text dot length is less than or equal to 0. So if the length of this text is less than or equal to 0, then we know that we've probably not typed it incorrectly. We could do more checks in here to make sure it's valid, but we'll just assume if they've just clicked join without realizing, then it'll try and join the local host. So we can copy and paste this line right here, and we can set this, instead of setting it to whatever the input field is, we can just set it to this default 127.0.0.1, which will be localhost, and it'll either connect or it won't, meaning this can be inside of the else. So if everything else, so if they forgot to type anything in, it'll set it to 127.0.0. Otherwise, it will set it to the value that was typed in. And hopefully that will be the IP address of the computer that you're trying to connect to, which should be obviously available through their firewalls. And then we just run this start client and set the menu panel inactive so the buttons disappear. So we need to set that up now. So if we've saved this, we can go back to here. The network manager, sorry, game canvas is where we added this input field. So we need to make sure that we take this input field value and drag it into this input field so that the menu script does have access to that input field. The button, the join button, if we click on join button, we'll see that we're still running from the menu script the join method, which is the one we're working on here. So in theory this should work without typing anything in. It should set this to 127.0.0.1 and it should run. So I'm going to pause the video and just test to make sure that it does. So that worked as expected. You're able to, you'll see that you're able to play on one side, and on the other side, if you try and join without typing anything in, you'll be able to join the game. So if I host over on the side and run this one, and if I just click join without typing anything else in, without typing an IP address in, it will still join, so we're still in the same game. However, you can also get the IP address of your computer, and I'm assuming if you're doing a multiplayer tutorial, you already know how to do it. If you don't, it's fairly simple. You run a command prompt, you type in ipconfig, and when you press enter, it'll give you the IP configuration of, the IPs of your computer, and you're looking for the IPv4. So the IPv4 address of your computer is the one that you're looking to type in. You type those values in to the box over here, and you'll click the join, and you'll be able to join over your network to your computer. And it sounds really weird because you're on the same computer, but if you had multiple computers across your network, you'd be able to type in that IP, click the join, and it would join as long as it was the IP was accessible through firewalls, etc. So yeah, that's the first part of this. In the next part, we're going to cover making sure that it's actually the right version of the game. So I'll direct your attention to the MLAPI documentation again. It's interesting how one of the first things that's covered is one of the more complicated things that I've left till the end in my videos. Connection approval is really important, and it's a difficult thing to do for network games. The bottom line is, if you connect across an IP address, and the connection is automatically allowed, then you can in theory be playing on a different map, and your data will be getting sent across the network and try to synchronize. So you can join games that you're not allowed to join effectively. So there has to be some system in place, and the connection approval is fairly, it's not completely arbitrary, it's not really simple, and but it is very powerful, and the way that it's done with MLAPI is pretty cool. So you can see from the documentation that basically there's an approval check, and inside of like a start method or whatever, you define this approval check so that you run this particular value, and so this runs a particular method that you've defined inside the parameters from the approval check, so that you're able to actually spawn in a client. Now, obviously, if you're the host, you don't need to do this because you're the host. But in some ways, it seems weird that there is no parity between the two. So I'm going to just quickly show you how to do this. So this approval check, and then we'll just write some simple password so that we can ensure that that it is the correct game version that you're trying to connect to, and it'll only spawn in a client if it is the correct one. So we'll do this just in this same method, in the same class. So in this menu script, it's starting to get to the point where I might need to refactor the code, because right now a menu script doesn't make much sense that it also does approval, but we'll go with it anyway. So we want this start method so that we can set up what method we're going to run for the approval check. So I'm going to keep this documentation because I can't remember all of it, but we're basically doing this part, this line right here, and then we write whatever we want inside this approval check method. So I'm actually going to copy that and go back to my code, and we want inside of the start, so for the singleton, we want to create this approval check method so that we know that for our only network manager on this machine, we're going to run this method. Now you'll see this is quite cool because if you get a mistake, it allows you to generate that method. So Visual Studio, I'm on 2019, but 2017 does this too, where it will generate that method for me. It doesn't name them very well. These arg1, arg2 doesn't make a lot of sense, but you can go back to the documentation to see what they should be. So there was connection data as the first byte array, and then client ID, and then there was the method name that you'd like for the delegate. So we'll do, so it's connection data, client ID, and delegate. So we'll just use those instead. So it would be connection data, and this one was the client ID, and the last one was the name of the method that you're going to run. So they called it callback. I'm going to call mine callback as well, and we can avoid, get rid of that part of the code because we don't need to do that. So in theory, when a client tries to connect, it will run this method and it will run whatever bits of code is in here. And you can see from the documentation that effectively we're going to define our own logic to decide if we're going to approve or not, and then we're going to create the client and connect it. This is in the next video I might do, if I have time, this is where we can define spawn positions. So we are able to spawn in at particular spawn locations because we can choose a spawn location and a spawn rotation when we confirm that we're going to allow the client to join. So the join is where this is going to actually happen. So the client is going to attempt to join, and hopefully it'll run this approval check method. So we'll start writing some code for that. So I'm going to create an approve, a boolean, and I'm going to set it to false right now. And then I'm going to check this, I'm going to change this to true if the connection data is what I expect it to be. So the connection data is sent when somebody tries to join, and if you can see from the documentation, you can set the connection data in the most long-winded possible way. It needs to be, for some reason, so that they can add some security in the background. They have it as a byte array, which means that you need to use this massive long thing just to get this get bytes from a particular string of data. So again, we can literally copy and paste this line, and we'll add this to our code inside the join. So just before we start our client, so assuming everything else has gone correct, we can put this piece in and we can change this to our password. So I'm going to make this an incredibly complex password. I'm going to call it my game, and that way this data, which is controlled by the network manager singleton, this data will be sitting there and it will be sent when a client tries to connect. So right here, we need to do more or less the opposite. So we're going to say if the connection data is correct, then we join. Then we approve, I should say. So the connection data, to work out if the connection data is the same, we need to kind of do the opposite of what we just did here with this part. So the system.text.encoding.getBytes also has a system.text.connection dot, and then if you do that, you can see get string. So the get string method reverses it. So I can pass in the connection data, which will be the thing that's sent, the byte array, which is sent, and this get string method will return it. So I'm just going to go and call this, I'll make it a string password, good spelling, password equals. So this will get the string back, and if the password if the password is equal to, what did we decide it was? My game. The string my game, then we can join. So we just make approve equal to true. In theory, nothing else. We should just exit out at this point, so nothing else really should happen. If the password is not correct, nothing else should happen. But from the documentation, it does kind of say that you can you try the callback anyway, and then if the approve is false, it will handle it from the network manager side. So rather than us handling it, so we don't even need to care about whether we're going to create the player object, because we totally want to create the player object. And you'll notice from the documentation here that we can create a default hash from it, which is like a unique identifier for a particular object. But you'll see here that if you're using the default player, then you don't need to do it. So the callback, this one right here, I'm going to copy that as well so we don't have to waste time. And then so we know that we're approved, so we can run this callback. So approve will either be false, which is its default value. If we manage to get the connection data it's correct, then it will be true. And so the callback that we're going to run is, so we want to set this, so this is whether we're going to create the player, and we'll just say true. The prefab hash, we can leave that as null because it will just set it as it is. Approve is this value, it'll be true or a false. And just for the sake of this video, let's just say just create a vector 3. So we'll just say 0, 10, 0. So it's up in the sky. Let's make that a new vector 3 so that works. And we need a default rotation, so we'll just make a default quaternion, quaternion.identity, so that we've got a position and rotation to spawn this new client at. So hopefully that makes a bit of sense. I'll quickly go over it again. So we create some connection data by passing a string as a bunch of bytes into the connection data for the singleton. And then at the other end, if we're connecting as a client, we're running this approval check, checking to see that it is correct, that it is the same password. And if that's the case, then when we do try and spawn the guy in, we've set our approval to true, so it should work. So I'm going to pause the video and just test to make sure it does. So when I did run this and didn't get quite what I expected, I will show you what mistake I made. So in the network manager by default, oops, reload that one. So in the network manager by default, the connection approval isn't set to be true. So you can see in your network manager for your project here, there's connection approval under connection. So this value, this connection approval value, in order to check for connection approval, you need to make sure that this is ticked, and there's like a timeout thing that you can do, so that you can, it will take time to potentially do the connection approval. So this, you tick this on and save the scene. So in the other one, that gets forces you to reload that scene. To prove that it does work, what I'm going to do, and it's just good to have it, and I wanted to show you just because, why not? So if I do your debug.log, what I'm going to do is I'm going to just debug the approval state. So I'm just going to do that and put approve in between the curlies. So the debug.log will run, and you'll see that when we do this, the approval check actually runs on the server. So the client tries to connect, the approval check runs on the server. So this on the server should say approval and then whether it's true or false. And this just allows you to test thoroughly. So if you're going to make sure that it's going to work, you need to make sure that it's going to work properly. So we'll go back to here, clear this one. I'm going to run it up here, and we'll host on this side. So nothing appeared yet in the debug.log. And if I click on this one, and run this one, I should be able to just connect with a join, and you'll see on the left hand side approval true, so it was approved. You can test it yourself, and it's a good idea to do that. If you change the password so that the passwords don't match, so if you have password of my game and test it against something else over here, you'll see that you'll get that approval is equal to false, and the thing will time out and it won't connect a client to the network. So yeah, that's how to get it to work on another computer across a network. So hopefully that's not too confusing. It seemed a longer video than I fully expected. I thought I'd be done it quickly, but there we go. So hopefully you're still enjoying the series. I will possibly do one more video on setting up, or using this piece of code here to set up specific spawn points for players around a map. But yeah, like and subscribe, and I'll maybe see you in the next one. Cheers.